Problem 39, it wants to know all the members or elements of the set A, and that's the numbers 1, 3, 4, 5, 9, 10. In problem number 40, we're asked what are all the numbers in the universe, and I could list them all, but I don't feel like it. So let's say it's the set of all x's such that x is an element of the natural numbers, and x is in between 1 and 14, but it can include 1 and 14. So we have the set of all x's such that x is a natural number and x is included in between 1 and 14. Problem number 41 asks us for all the elements in the set C. And so I'm going to go back to listing. That's 4, 5, 6, 8, 9, 11. And we're done with those three. Problem 42 asks us for the complement of B. That's everything that's not in B. So let's try to write down that set. B has all these numbers here, so let's go outside of the circle B. We've got 1, 10, 9, 11. And we've got 2 and 13. I could take the time to put them in order, but I don't feel like it. So let's go on to the next problem. Problem 43 asks us for the intersection of A and B. They want all the numbers, the set of all numbers that are in A and in B, where they overlap. And that's 3, 4, 5, just visually from the problem. Problem 44 wants A intersect C. That's similar. It's everything that's in circle A and in circle C. And that looks like these numbers right in here. Looks like 4, 5, 9. Problem 45. It's a little bit more involved. It's the intersection of B and C and then the complement. So the intersection of B and C and then its complement. And so where's the intersection of B and C? It's all these numbers in here. But the complement of these numbers is everything in the universe that's not those. So we want the numbers 1 through 14, skipping 4, 5, 6, and 8. So 1, 2, 3, we're skipping 4, 5, 6, 7, we're skipping 8, 9, 10, 11, 12, 13, 14. Problem 46, we want the intersection of A and B intersected with C. We kind of go from left to right since we don't have parentheses. So the intersection of A and B are the numbers 3, 4, 5. We already have that. They're up here. And we want the intersection of these 3, 4, 5 with everything in C. So what is in both 3, 4, 5 and in C? Well, it's 4, 5. In 47, we want the complement of A union C. A union C are all these numbers inside the A and C circles. So the complement of that is everything that's outside of the circles A and C. Well, that's the 7, 12, 14, and the 2, 13. So let's put those in. 7, 12, 14, 2, 13. And there we go. What about number 48? It's B union C, and then the intersection of that and A. And so where's B union C? B union C is everything in the B and C circles, and then we want to intersect that with everything that's in the A circle. So what part of A is in B or C? Well, it's this 3, 9, 4, 5. It's everything that's in A that's not only in A. 1 and 10 are only in A. The rest of them, 3, 4, 5, 9, are shared. Problem 49, we want the complement of whatever A minus B is. A minus B is everything that's in A that's not in B. So look at this circle here. What's in A that's not in B? Well, it's 1, 10, and 9. So this part here, this subtraction, is the set 1, 10, and 9. But now we want the complement of 1, 10, and 9. That means we want everything that's in the universe except 1, 10, and 9. So 2, 3, 4, 5, 6, 7, 8. 9, 10 are not in it. 11, 12, 13, 14. So it's all the numbers from 1 to 14 except 1, 10, and 9. Problem 50 looks similar, but it's really kind of different. It's a different subtraction. We're taking the complement of A and we're subtracting off B. The complement of A is everything outside of A. So everything outside of A are kind of these numbers right there. And we're subtracting off stuff that's in B. Well, that's in B, that's in B, that's in B, that's in B, that's in B. So what's outside of A, but also outside of B? That's kind of, we want them to be outside of both, and it's this number, and this one, and this one. So that's a little bit trickier of a problem in a way. There's some more thinking involved.